to modelize the chemistry around the stars has been based on basically the soot chemistry around the stars has been based on basically the soot or the combustion in soot at the beginning. Where you this gives us a more hint that these type of molecules also could be synthesized action to give HAG or hydrogenated amorphous carbon, or to give birth again from soot to fullerenes or to large pH as fullerenes. The talks that I just presented here at the Nanospace second joint meeting entitled Tracing the Origin of Cosmic PAH Inside Stardust Analog or Cosmic Dust Analogs and Meteorites. Our main topics is basically laboratory astrophysics, that we try to understand the molecular composition of dust analog generated to understand the formation of stardust and cosmic dust, and also the composition and the molecular composition of extraterrestrial materials such as meteorites and sample from sample return missions. The whole idea is the development of some analytical tool, and we have a unique experimental setup that we developed during the NanoCosmos project, which was an ERC synergy project. And the idea was to give to the community a tool that is very sensitive to polycyclic aromatic hydrocarbon and fullerenes. And polycyclic aromatic hydrocarbons are a dominant portion of carbonaceous materials that are in space, and also they are the main product of soot combustion and pollutant on Earth. So the idea is to be able to take up this molecule or to know the composition of a sample by studying its molecular composition. To do, we have developed a technique where you use a laser desorption first to be able to generate the solid material to the gas phase, and in the second step, with a UV laser at 266, we specifically ionize these polycyclic aromatic hydrocarbon and fullerenes. This technique is unique in the world. Like 99% of the people that use this technique in laser mass spectrometry, they will use a single laser, mostly in the UV, not in the infrared, to be able to desorb and ionize these molecules. However, using single laser desorption ionization could create sometimes a problem or artifact by doing some chemistry in this plume. In our technique, we really separate the desorption from the ionization process, giving us an unmatched sensitivity going down to few attomoles or a few femtograms. We have been able, during the past 6 to 7 years actually, to analyze different type of material, dust analog generated in the Stardust machine built by the CSIC in the NanoCosmos project. We have been able also to track the chemical evolution of PAH inside soot particle by sampling soot particle at different height in the burner zone of a flame of ethylene. And we have also in parallel to the samples that we do in the laboratory, or we synthesize it in the laboratory to be an analog for the cosmic dust. That's a way of knowing things. The second activity is basically analyzing extraterrestrial samples, that meteorites that hold some pre-solar material that has been altered during the journey of this sample from the interstellar medium to the planet formation system. So having access to meteorites is something that is accessible on Earth. We have a huge quantity, and we can analyze especially carbonaceous chondrite, which are the meteorites that contain most of the organic material and are interesting for the people studying the origin of life, which is not our main activity to study the organic and origin of life, but PAH also has a role in this study. So we try to develop or to analyze this meteorite. We have been analyzing this meteorite. We have some discovery by detecting some fullerenes, not in carbonaceous chondrite, but in other stuff. And actually now we are trying to analyze a large set of these carbonaceous chondrite to make basically a large database and having a larger idea about the diversity and the heterogeneity of these molecules in different type of carbonaceous chondrite. Also, I presented very quickly, without presenting the result, because we'll be submitting our results soon, the analysis of the Hayabusa 2 sample that has been given to us following a call of offer by the JAXA. So by collaborating with the JAXA Curation Center, we get these 2 grains, and by discussing with them scientifically and on other ways, we have been able to analyze this sample, and we have a great results. We cannot talk about them now, but
probably in the next meeting, I will hope to present this result. So stay tuned and hope that that is fine. That's it.